Welcome to Physical Science Laboratory number 8. This will be in two sections. The first part is about chemistry laboratory techniques. These are the sorts of things that normally I'd be there demonstrating to you how you do all these different factors or functions in the laboratory. And the second part of it is going to be built upon the information that you learned last week in terms of how certain chemical structures look. And I've had some fun working with some chemistry models on that. But I'll walk you through this. You can read it more slowly at your leisure with any time you have left at home. But anyway, the first part, the first thing you have to do is weighing out solid samples. And there are certain rules for that. Never place a chemical directly on the balance. Usually use filter paper or a beaker or something that you're weighing the material into. Also, when you have that filter paper there or something you're weighing it onto, you usually crease it before placing it. And what happens is by doing it in that way, it's easier to then transfer that material from the paper into whatever container you're going to put it into. You tare it before the balance before adding the chemical. That just zeroes it out. Use a spatula to add the chemical in a precise manner. Now, in terms of tearing the balance, at times you may want to know the weight of your beaker or certain other things. So you don't always hit the zero button on there. You make certain that you have it at zero before anything that you want to record is on there. And you use a spatula to add a chemical in a precise manner. You use a dropper to use in something else. And never you return the unused to the original container, but we dispose of it properly. In terms of transferring liquids, they're normally poured from the original container into an appropriate sized beaker. Then once you go from that beaker, you put it precisely into a flask or beaker or other container. So the initial beaker just serves as a secondary, as a primary source for the one you're going to be loading it into. So when close to the correct amount, use a dropper or pipette to get the exact amount in that one, and dispose of the remaining chemical liquid from that first beaker as appropriate. Another thing, new chemicals. You saw that we always have a material safety data sheet with any new chemical we have. You should always make certain you're familiar with all the hazardous conditions and just making certain you know what's going to, any precautions you might need to take. Heating things up. Flames are never used with organic materials, of course, because they will ignite. With inorganic materials, bending glass, flame tests, you use that flame very carefully. Electric hot plates and heating mantles are the most commonly used when heating the organic materials. Be careful not to turn this equipment to its highest setting, which can lead to a burnout of the hot plate itself. The disadvantage of hot plates over the direct flame is that it does take several minutes for the instruments to reach the desired temperature. Heating mantles are plugged into a variable rheostat, which provides a great deal of temperature control. So when you're doing a distillation operation with round bottom flasks or things like that, that's when you usually use those heating mantles. The next thing is utilizing volumetric flasks. Those are the ones which you saw from the laboratory assignment that you turned in today. Those are the ones that are used to prepare exact chemical solutions. So you measure and add the solute for the solution, add enough solvent to dissolve it, and continue to add solvent until you have the line marked in the solvent flask. And use a pipette or dropper to fill it exactly to that, making certain you're using the meniscus and that you're viewing there. Then you seal it up and invert it thoroughly to mix the solution. Okay. Now, if it is something that is going to be mixing, a lot of times there's heat evolved there, and so that the gas that you have could be building up pressure. So each time you invert it and take it back, you take the topper out of it and then reinsert it so that you don't build up too much pressure at any one time. It's terrible to shoot one of the tops off at one of your lab mates. That's called horseplaying. We don't do that, of course. Titration is a slow addition of one solution of a known concentration, the titrant, to a known volume. And this right here this portion of it was covered in the lecture earlier today. Since it often happens that it may be overshot, proper planning requires another burette with a counter reagent to position in position, so that you can then add that back to it if you do overshoot it. But if you just relied upon a color change, go in very, very slowly as you get closer and closer to that equilibrium point. Okay, the next part is filtration. Filtration is used to remove an insoluble solid that's suspended in solution. During the lecture today, we talked about gravimetric analysis. Gravimetric just means that you're weighing it. But what you have to do is you want to know exactly how much of that precipitate you have in your solution. And there's two different types of approaches. There's a gravity filter funnel, and they say when you don't want the solid, sometimes you just don't have the vacuum filters or other things. The gravity filter funnel is, if you do want that solid, you have to have a lot of patience, because it's going to take a long time for just gravity to pull that down through your paper. With a Hirsch or a Buchner funnel, what you can do is you can utilize a round filter that fits into it, and then so that you can use a vacuum to pull the liquid through that. Usually a water aspirator can be used. You have to make certain that nothing backs up. House vacuum, I don't know. I don't think we've ever. Maybe they mean a laboratory vacuum, okay, by the in-house, because it's not. This is not the vacuum line that you're used to clean your floors at home. This is a vacuum line where there's a central vacuum source for a laboratory setting. So this is a lab vacuum line, not your house system. Just prior to pouring the precipitate onto the filter, you usually wet it with a few milliliters of the solvent and apply vacuum. This has caused the paper to stick. You do the same thing when you do it up here. You don't want there to be any gaps between the filter paper and the funnel. So, and then what you do here is you fold this into quarter flutes, and there's a way of organizing that to get it to set solidly there, so you don't lose any of your precipitate. Receiver flasks, okay, this is where the solution, the solute, the material that is not in solution, can go through there, and sometimes you're trying to collect that for a process as well. So you can secure that and distill that, or do whatever you need to do for that material. Crystallization is used to purify a solid. Once you have that filtrate, it's possible for you to take that material and put that into a vacuum oven, so that will pull off the rest of any other materials. And so if you want to get crystal, you'll get some sort of valuable crystals out of this one. But sometimes you can get your crystals directly from a solution. And if you have a super saturated solution, you can heat it up. And this right here should have been a superscript, 0 to 100 degrees centigrade, for hydrocarbon solvents such as hexane and petroleum ether. And then you can pull those off of there, or cool them down, so that you can then have it, you get a supersaturated solution, which upon cooling then causes your precipitation or to form crystals very, very nicely. There's an example online. It's called hot ice, where essentially it utilizes acetic acid, or essentially vinegar, and bicarbonate of soda. And what you get are crystals of sodium bicarbonate. And it's an interesting one to watch. I'll post that link to that at a later date. So the idea is to demonstrate the proper techniques for each of these following ones: weighing a solid, reading an MSD sheet, weighing a liquid, and heating the test tube. The heating of the test tube is something where you make certain you never point that test tube at a lab mate or the instructor. And what you are, because in case something comes out of that test tube, a hot gas or a fluid splash or something like that, you don't want to essentially have a Roman candle that you're aiming at someone. The next part we're going to talk about are chemical models. So using the chemical model kit, make the following compounds. Well, I did that. Here is the first set of those pictures. Okay? And so what we have here, if I can get this to slide over, this right here, water is H2O. Oxygen, and this is the red one, is oxygen. And these are the two hydrogen ones. And oxygen has two places where it can form a bond, and it also has two non-bonding pairs. Okay? So this right here is what the structure of a water molecule would look like. If instead you had another one, sorry, where did I go? Okay. If you had another one that involved 3 atoms, carbon and 2 oxygens, you'll notice that that forms double bonds. And you'll see that the double bonds are in this direction here and this direction here, okay? Because the 4 positions are at tetrahedral locations, or the corners of the tetrahedron for the carbon atom. This is seen more easily in this one right here, where you have a carbon atom at the middle, and each one of the corners has a hydrogen atom associated with it. So you can see that this right here is lying flat on the paper. This one's sticking straight out towards you. So what you are supposed to do in this section right here for these 3 different ones is draw diagrams of these indicating what molecule is there and how the bonds are and the regular orientation of these, okay? So this is sitting upwards a little bit. This is 109 degrees on each side here, and this is sticking straight up. You might have to do a couple of different versions of this one so that it looks acceptable. Okay, let's go to the next one. Okay, let's see if I can get this over. And we'll pull up the next one. Here we go. And this one, we've got 2 of them here. One is propane, 3 carbon atoms. And you can see that each carbon atom has 4 different bonds associated with it. 1 to hydrogen here, 1 to hydrogen here, 1 to hydrogen here, and a carbon-carbon bond here. This carbon also is linked to a carbon there, but there's only 2 locations left on this carbon. One goes down and one comes up straight out of the paper. And this one goes out this way. These 2 are down on the flat paper, and this one is sticking up in this direction. So you've got 1, 2, 3, 4, 5 hydrogens that are flat on the paper, 1, 2, 3 hydrogens that are right sticking out of there, and this right here goes up and then comes back down. I think we'll stop there on this one, and I'll begin describing the acetic acid molecule down here on the next part.